Okay. Okay, yes, so I'm going to be talking about using black soldier flies and how effectively they can reduce fecal sludge from pit latrines. Next slide, please. So my PhD is at the London School of Hygiene and Tropical Medicine, and I'm looking at overall the efficiency of black soldier flies and their effects on reducing pit latrine material. And today I'm going to be focusing on one objective, which was looking at 3 different variables: the feeding rate, larval density, and moisture content of pit material, and what effects these variables had on the waste reduction when fed on by black soldier fly larvae. Now, this work was conducted in South Africa, Western Cape, with Stellenbosch University and AgriProtein and Biocycle. Next slide, please. So a little bit of background for people who don't know about black soldier flies. They're a species that's found all around the world in the tropical regions, about 40 degrees north to south. And unlike the housefly, they're a non-pest species and they don't spread disease as well. Now, the stages that we focus on are the larval stages and the prepupal stages. So the larvae are detritivores, so they'll consume almost any organic material, and they're also voracious feeders. They can grow up to 10,000 times their body mass in a matter of weeks. Now, the value that these insects have is that the prepupae, the final larval stage, are very high in fat and in proteins, and research has already shown that when fed on animal manure or municipal organic waste, they can be a replacement for conventional proteins and fats such as fish meal. Next slide, please. So the aim of the experiment was to look at as I said, 3 different variables: moisture content, feeding rate, and larval density. Now, I looked at 3 different levels of each of the variables and combined all of them, leading to 27 different combinations. Because of the feeding rate and larval density interaction, that meant the larvae got fed either 140 grams a week up to 1.6 kilos of pit material a week. And they were re-fed every week until they started developing into prepupae, which was about 4 weeks long. Next slide, please. So first off, I had to collect the pit material, which I did by identifying the right latrines, suitable latrines in an informal settlement in South Africa. A suitable latrine was one that had solid pit waste, no chemical use, and it was accessible. You could actually get into the vault below it. So I removed the top mound and top 20 centimeters of the pit material and transported it back to the laboratory. Here I mixed it together in a mixer and removing any garbage that might be found in the waste. And to increase the moisture content, I added water to some of the containers of it to get it to 75 or 85% moisture. Next slide, please. Oh, back one. So the experimental setup, what I had was I fed the larvae, I had lots of different containers, and I'd add the pit material to the containers. They'd be paired in either as a control without any larvae added, or a treatment where they had 6-day-old larvae added to the treatments. These would then be stored in an experimental room that was kept at about 27-28 degrees centigrade and 80% relative humidity. The material, the containers, and the larvae were weighed every 3 days, and then every 7 days they would be fed a new week's worth of food. So if you can see in the little picture E, I had the containers designed so I could move a divider, so the height of the feeding material was always the same. Okay, next slide, please. Here's some pictures of some of the results that I had. On the left-hand side is one of the high feeding rate, high larval density quantities of food. So this was getting 1.6 kilos of food every week. And the one on the left is the control, where there's no larvae in, and there was very little waste reduction in this, just down to dehydration and microbial activity. Now in the middle is the same treatment combination, but with larvae added. So from this there was higher waste reduction than in the controls, but it was still relatively low. And the result was there was quite large pre-pupae produced from this experimental combination. And on the right-hand side, there's the treatment that had the very low number of larvae and a low feeding rate. And this resulted in a very high amount of waste that was reduced, but the pre-pupae that developed on it ended up very, very small, especially in comparison to the other pre-pupae. Next slide, please. So here is a bit hard to make out on the screen here, but here is a graph representing the waste reduction in the blue bars, from highest on the left to lowest on the right. Now, the numbers down at the bottom, I've taken moisture content out of the equation here, out of the analysis here, because that, although it was significant in the results, it wasn't as significant as feeding rate and larval density, and it's a lot easier to show it here. You can see that where you have high waste reduction, you have the lowest pre-pupal biomass, and at the other end of the scale, where you have the lowest waste reduction, you have the highest pre-pupal biomass. That just kind of supports the pictures I showed earlier. Next slide, please. So yeah, as I just said, with high waste reduction, you have low biomass. With high biomass, you have low waste reduction. Now, there's still a whole lot of data to be analysed on this, and we're estimating that what people are going to want is somewhere in the middle, where you're getting an adequate waste reduction, where you're not left with a lot of dangerous material, but you're also getting a good quantity of pre-pupae from they providing a value to your process. Future work that needs to be conducted, as I said, is to continue doing this analysis, and I'm in the process of writing up that at the moment, in fact. But also, we have to ensure that there's methods of processing the pre-pupae to make sure they're safe to be fed to animals. There's other issues, including heavy metal bioaccumulation that's within the pre-pupae that need to be looked at too. Okay, next slide, please. And here's just a list of people involved in the project. So, thank you.
Thank you, Jan. Very good